Yeah. So welcome everyone to this PYQ session. Today we will be discussing the question paper which appeared in the last term's electronic system course. So in this term, both the system commands and electronic systems Linux shell course are following the same pattern. That is why we'll be taking this like this question paper. All right. The takeaway I want you all of you guys to take from this is that just focus on the pattern and regarding the questions you can the questions itself you can sort of take an idea about like how the questions are structured. Also for practicing further questions you can refer to other PYQs. The sessions have already recorded and available on YouTube from earlier terms. Okay. There will be one or two questions which have a wrong options here, and also one question here is out of syllabus. I'll mention that when I'll come to that. Okay. So starting with the first question, uh, Ajit is writing an essay in English. He realizes basically this question is asking you to replace the words color and program slash program. He has made some mistakes, and that's why he has written both color in both American and British English. So we just want to write a regex which is able to match this color and program words. All right. So going to the options, first option has a question mark after the O. Last option has three question marks after the program. Third option has a question mark after U, and the last option has a question mark with a grouping around ME and then a question mark. All
Sir,
right.
can you please zoom in a little bit? And now it's fine. Thank you.
Yeah. So what the first option is doing, so the question mark quantifier, question mark is a quantifier which essentially tells that match 0 or 1 of the preceding token. Token can be a character or a group of characters, right? So in the first option, this is incorrect because we are putting a question mark after the O itself, which will result in matching a COLR, which is not a valid spelling for color. In the second option is an invalid regex because we have put three question marks subsequently. And so what the first question mark is doing here, first question mark will match 0 or 1 of the previous token. The second question mark will make the first question mark matching lazy, and the third question mark is not a that's where it gets invalid. So that's why this regex is invalid. Even if we didn't have a question mark at the end here, then also this regex would be invalid because it won't match the program, the end, like both the versions of program, both in British English and American English one. As for the third question, this will correctly match both COLR and COLOUR since we have put a question mark after the U. So one match would be without the U and another match would be with the U. Similarly, in the fourth option, just adds a bracket around ME. So the bracket around ME is what makes it a group. Now ME will be considered as a single token, and the question mark will act on both M and E entirely. So this will match program and also a program completely with the ending with an ME. I can go in and show you, practically demonstrate this. So let's say we have color and we have COLOUR. Also we have program and program with the ME. So now in the the third option, there is a question mark here. So that way it matches the first characters, and for the U there is a question mark which allows it to escape U in one case and include U in another case. Okay, so that's for the color. Now we'll go to the program one. So program. So now this will match the entire British version. But if we want to remove the ME, since we have to match the one without the ME as well, we can put this in a group and then we can put a question mark ahead of it. Now we'll match both the instances. All right.
If we use, sir, if we use instead of bracket again, where after PROGRAM a question mark, then what will be the difference between this bracket, using this bracket and question mark?
Without the bracket, only question mark.
Yes, yes, yes.
So that won't help now, because we have to either escape both, like the entire ME part, or only keep the keep the program part, or exclude all the entire ME part. If we do a single question mark after E, then the only E is getting escaped, which won't help us. All right.
Okay, okay.
So could you please explain the second option again? The program with the
Triple question mark,
P.
right?
Yeah, double
Yeah.
question.
Okay, so this results in an invalid rejects, as you can see. So what the first question mark does, it will escape the like 0 or 1, the previous M character. Then the second question mark is basically what makes the quantifier lazy, and the last question mark adds it's an invalid like rejects format. So it really, I mean, it's not a valid thing. That's why it's an invalid rejects here.
What do you mean by lazy, no, in the second question mark?
Huh?
Lazy means what it will do?
Yeah, lazy means that by default the quantifiers are greedy, so they would match the entirety of the the largest possible match that can be made. They'll match the largest possible version of the regex of the string.
So if we give only two question marks, then the first program will be considered.
No, because that also will not match correctly, because we are escaping the M, not matching
Okay.
the program entirely.
Okay.
Yeah. So, okay. I'll go into much more detail later on. I'm just covering, sort of explaining basically. Okay, so let me just try and explain the lazy concept also. Maybe quickly I can explain. So in the this in regex is, there is a concept called greediness and laziness. So what greediness means is that the whatever token you have, it sort of wants to match the largest possible match which is there, to give a like a output. But what the question marks adds at the end, it makes the quantifier lazy, which means that it will match the shortest possible instance which it can match to get an output. So that's what's the difference between greediness and laziness. By default, all the quantifiers and rejects are greedy. Right now, I mean, I'll have to get an example for exactly to work. Maybe BCC. This one. Yeah, so you can see here. So when I put A plus, B plus, and C plus, what it essentially means is match one or more of A, one or more of B, and one or more of C in that sequence, right? But if I put a question mark here, you can see that the last two C's are escaped. So that's what I'm trying to explain with the laziness. So by default, they're greedy, meaning the largest possible match. But when I put a question mark, then the shortest possible match will be returned, which satisfies the rejects. So that is the difference.
So in the question, the program, the first the first M, the first question mark will take care of the first M, and the second question mark only. I mean, it's only uh, since the first question mark only takes care of the first M, the second question mark make it lazy, and it won't match the second M. That is what it's doing.
No, that's, I mean, the rejects is first of all, it is invalid, because we are using three question marks, and three question marks means nothing essentially. So we'll have to first get
Sir,
rid of the last
sir,
question
please
mark.
please give one question mark, two question mark, three
Yeah,
question
yeah,
marks.
yeah. So right now we have three question marks, right? Just look at the output at the bottom. It mentions that the last one gives an error, and the first is for 0 and 1, and the second is making it lazy. So I'll just remove the last one. That will remove the error. All right. Okay. Now I have removed the last one. Now what is happening? Essentially, the lazy thing is doing nothing here. Even if I remove this last question mark, okay. So one thing it is doing, it is okay. So basically making it lazy. So even if this M isn't matched, then also it will be considered even if this M isn't considered, then also it will be considered a valid match. That's what the lazy one is doing. If I, so let's say now I put a question mark. So now the largest possible match is there. See, it's the same concept, because a largest possible match will include the M. That's why they are considering the largest possible match. But if I put a question mark in front of it, then that M won't be included. All right. And only the program, the M will be removed, because now we can match only PRO GRA without messing with the M. So
with some other alphabet, at last, and with one question mark also, it matches the string, no?
Only one question mark?
With some other alphabet at the end. In
some other alphabet as in
the input, yeah. M question mark means with in the place of M we have some other alphabet also. It matches, no?
Acha, so what are you saying? What you are saying is that if we had a instead of program we had PROGRE, so yeah. it won't do it, because we are only looking for either a presence of M or nothing.
Oh, so at only PROGRA will be matching.
Not the entire thing. Also, this is like even with a single question mark, this is wrong. Even with double question mark, this is wrong. Even with triple question mark, this is wrong, because we are like every time we are excluding the ME part, not matching the ME part. So that's the thing with this question. So basically, the important concepts is the here in play are that one is the greedy one, right? I mean, not really entirely there are greediness directly used, but I mean, because the 3 question marks, it makes it invalid. But if it were instead of 3 question marks a double question mark, and then they said that okay, you have to match a program and you can maybe escape the one with ME and not match it entirely, then definitely the greedy concept will come in play. So, I mean, these are basically 2 advanced concepts. One is the greedy concept and one is the grouping concept. I've covered these concepts in my TA session, I believe. Okay. And tomorrow also there is a instructor revision session. You can note down these concepts and then ask the instructor to clarify them. I'll be moving ahead because right now I'm recording this session, and so I'll be moving to the next question. Okay. So in this question, they are basically asking us to set permissions on a file.txt. The permissions we have to give are read, write, and execute for the that user, and for the group we have to give read, write. As for the others, we have to give the read, write as well, read, execute as well. So B and D are the correct options here. I'll go back here and sort of show you this slide. So U user, G for group, O is for other, and so basically how the permissions are structured is that they come in this order: U, G, O, and RWX, RWX, RWX. Whenever a permission is not desired for a particular group, for a particular like category of access group, then we just put a dash. There is this is represented by a dash there. So what's actually happening in the background is this dash is interpreted as a 0, and whenever there is a character here, it gets interpreted as a 1. So basically a binary number that's getting generated here. So you can see a presence of X will mean a 1. If we remove a X, it will just turn it to 0, right? And similarly for R and similarly for W. So since there is no W here, that's why we have put a 0 here. And the way you can get a number out of it is that you can multiply from two powers. You can multiply. So 2 power 0, 2 power 1, and 2 square. And you can multiply that by 1. Then you can add again. Then you can multiply 2 by 0, which will result in a 0. Then you can multiply 1 into a 1. which will result in a 1, and that's how we end up with 5. Now for 7, all of these will be 1, and so there will be a 1 here, so this 2 will also be added. That's why we'll end up with 7 here. All right, so some basic permission setting, nothing much more going on here.
Sir, could you please repeat that?
All right, so the way the permissions are structured, so basically we have 3 access groups. One is for the owner of the file or user, one is a larger group, and O is for other, like anyone else apart from the first 2. All right, so for each of them we have a set of permissions. One is the read permission, and there is a write permission, and there is an execute permission, which is represented by this RWX like sort of string. Then RWX again and RWX again. Now, basically, we represent them as RWX, but that doesn't mean that we are saving an R or a W or a X. So in the memory, what we are saving is only binary representation. So basically, binary representation meaning on off, right? So on means when the permission is present, off means when the permission is not present. So basically, since I've taken example of the R-X here, so since W is not here, that's why a 0 for W. Since 1 is there, so 1 for R, and X is there, so 1 for X as well. Now this is just a binary representation. You can multiply this binary representation with the powers of 2. So 2 square is 4, 2 power 1 is 2, and 2 power 0 is 1 itself, and then get the output as 5. That is the numeric representation of the permission. So this basically this 5 here is the numeric representation of the RWX here, and R-X also 5. Now for RWX, this 0 will turn into a 1, and then you can multiply the 2 with the 1, and then it will be 4 plus 2 plus 1, which will be 7. So that is why the numeric representation here is a 7. All right. So that's how we get a numeric representation from the RWX, like character representation, interchanging. All right.
Understood, sir. Thank you.
If I'm correct, this wasn't explicitly taught in the class, in the lecture as in, right?
You'll find a lot of things which aren't explicitly taught, but they have been introduced. I won't be able
No,
to,
it was covered in the lecture. File permissions.
It was, I mean, it's largely the things will be covered. I won't be able to exactly point out where it is covered or not, because then I'll have to also go through the lectures.
So I just wanted to confirm. For example, we also saw question 1, and it was. I mean, okay, maybe for me, I saw it probably for the first time, question 1. But then I just wanted to confirm these things can come, which are not.
Yes, this is the actual paper, and the paper will be like this only. The week 4 deals with pattern matching. The entirety of week 4 deals with pattern matching. So that is, the question is from there only.
Question 1 is new thing, but question 2 is already covered.
Yeah, my main concern was.
I mean, they won't ask. See, even if they have asked here, they will give you a completely different thing. So, and they'll ask you to rejects for the completely different thing. So, I mean, because that's how it is, and it has been covered in week 4. I mean, you can't say that it hasn't been covered in week 4, because that is entirely pattern matching, and what pattern matching is essentially this only, creating rejects and all. Okay.
You told in the first course that is greedy, na? Greedy.
Greedy and laziness concept.
Yeah.
Right. Okay. So for question 3 this is from, I believe, week 3, which has process control. So this is just a question from that. So basically, it's also another theory one. So $exclamatory is a environment variable which stores the PID of the most recent background process. Right. And $exclamatory, if you put it by itself, then it will be interpreted as a command, and it will print like even. If I put a $exclamatory directly, or maybe I'll just first just put a background process. and then I'll just put a dollar exclamator directly. So this will be interpreted as a command, but we don't want that. We want to print out whatever is contained within this variable. So instead we do a echo. That way we get the printout of the PID. And also there is a difference between this printout and this printout. The difference is that this printout is getting passed to the standard error and this printout is getting outputted to the standard output. So even if you like think that it's in the question it is mentioned to give the output PID and this is also giving the output of the PID, even though it is an error. So that's also incorrect because this is forwarding it to the standard error and this will be forwarding to the standard output. Okay. Okay, again, then there is a PS. So PS is essentially it gives the output of all the processes running, and but jobs, what it will be outputting is jobs will give you a status but not the PID by default. Okay, so nothing more simple. Just run it on your VM and you'll get the answer. Moving on to the fourth question. Okay. So this is a bit of a tricky question. The options in this question are also wrong. So these are the correct answers as per the question, but in the paper it has been mentioned that C is also correct, which is not. Control Z is not correct here. There's a discourse post about it also where I have explained why it is incorrect. I'll explain the same thing to you right now as well. So basically, what they have given is sleep 200 and. So what sleep command does? Sleep command is used for just sleeping for a bit. So I can just write a sleep command and then I'll put, let's say, 5 seconds, and then after that I'll print a hello. Now you can see it is waiting. It will wait for 5 seconds and then after that it will execute the command. The subsequent command will be executed after waiting for 5 seconds. So that's just what the sleep command does. It just waits for that much amount of time that you have mentioned. Now the AND character, what it does is AND will send this process to the background. So if I type sleep, let's say I'll give a 200-second delay and then I'll type a AND character here. So if I execute this only, I won't get anything. My terminal will get back to me and this green, my roll number and everything will be printed out after 200 seconds. Okay.
Please sleep 5 seconds, please. So.
Acha, haan, okay. I'll show that. Okay, sleep. I'll sleep for 5 and wait. After 5 seconds, my terminal will be returned. See, it took some time. But if instead I put this this command and then type an AND, though my terminal will be printed instantly and the sleep command will go into the background. So see, so now this command is running. This command is still running. If I check the output of jobs, you can see that this command is still running. Okay. Here. That's why. But and I can type FG to bring back that command to my foreground, and I can press Ctrl Z to send it back to the background, and it also stops. The Ctrl Z also stops it. It stops it. It sends a sig stop signal, which stops the command. The same thing can be done if I do a sleep 200 and then I'll send a kill to. Acha, yeah, right now let me just give you the jobs. So we'll be this one is running right now, no? So what I'll do is I'll do a kill -20, which is the code, which is this is equal to this dash top and this -20 are similar. So and then I'll just type the process ID, which is 2841481. Now if I'll check the output of jobs, you can see that both of them are stopped. I mean, three was running previously, but the 3 is stopped now.
What is the meaning of kill -20? -20 meaning here?
-20 will send a sig t stp or a sig stop, and it is also equal to sending a -20 is equal to a dash stop. This is a signal which will tell the job to like stop. Okay. If you do a You can also do a kill, like directly you can do a kill. This will do without any options, 2841481, and then you can see jobs. Okay, so since it's stopped, that's why it's not working. Otherwise, directly if you do it, then it will sort of send a signal interrupt, which is what also gets sent when you do a control C. There is a table for this. You can check out the table on Google or wherever. In fact, it is also mentioned here in this sort of hint that they have listed. There are multiple signals, sig int, and then a sig stop and a sig TSTP. So all of these are different signals that they are there, and also the codes corresponding to each of the signals.
Sir, how did you retrieve the job ID?
Job ID. So whenever you send a signal sig stop, the job ID gets printed out.
Okay, sir. Okay. Yeah, sir. Another thing, sir, we are not able to watch this video on YouTube. It's saying that this video is private.
This video is private. It will be made public once the recording is done. Okay.
Okay, sir.
Here, process ID and job ID are different, na?
Process ID and job ID, no, they are the same. There is no difference between PID.
I did not get. Hello. Did not get that the kill 20. How 20 is varying?
20 is a signal TSTP. Signal TSTP. You can see here. This one.
So this is a list already saved.
This is a list. No. This you won't. Remember. You don't have to remember this. This will be given in the question paper if this question is asked. Okay.
Sir, these are what, sir? These are different types of signals or what, sir? These are
different type of signals which can control the execution of a task. So in like Windows, you have a task manager, right? In task manager, you can end task, stop task, terminate task. So similarly, all of these are in the like Linux system. These are used to stop task, start, continue task again, and cancel out of a task. Okay. So like I have given a brief explanation here also. So control C will terminate the foreground process. So this is signal interrupt. Control D indicates the end of file. It is not a signal as such. What it does is it will give the whatever command is being executed currently an end of file, which means the input has ended and you can do what, like, it's up to the command what it wants to do after that. Control Z will suspend the foreground process to background, and this will send a signal stop. So Control Z and kill 20 are similar. Also the kill stop and kill 20 are similar, but why this is incorrect here is because this is missing a dash before stop. So there should have been a dash here to make this command valid. Why Control Z is not a valid option here? Because Control Z only works on foreground processes, but in the question paper it has been mentioned that there is an end after sleep 200, and which means the process has been sent to the background. So Control Z won't work because the process is already in the background. If instead this end wasn't mentioned here, then this Control Z would be the valid option, and this kill command will be the incorrect option, because when you type sleep 200, then the sort of terminal freezes, and whatever you type, right, even if I type kill 20 whatever this ID ABCD, I mean it won't get executed anyway. So none of this will get executed because you are currently in the sleep command, right? So that is why. So now I'll have to press a Control Z, which will stop the sleep 200.
Control Z actually should have sent the command to the background. No, why it is
so stopped? It did now. It stopped.
It will not send to background, but it will stop. Control Z.
No. So the meaning of stopping the process is sending to the background. Once you stop the process, it automatically gets sent to the background.
It is still running. The sleep command is still running.
No, it isn't running. It is stopped.
How do we restart? FG command will restart the job. The stop.
FG command will bring it to the foreground again and restart.
So which job will be brought up? So there are three, right?
Last one. So when I type, so when I type FG here, the sleep 200 was this 441 was brought back. When I typed FG again, the third one was brought back. When I typed FG again, the second one was brought back. You can also like check this also. I'll start with a sleep 200 and then I'll give a let's say 150 and then I'll give a 100. And then I can, if I print the jobs output, there are now three processes.
All the three are running.
All the three are running in the background. Now if I press an FG, now this is the foreground process. Let me exit out of it. Now this is the second one. I'll exit out this again. Then this is the last one. All right. Now there is nothing to bring back. So that's what the error is. Current no such job is the error because all of them are done.
FG, does it take PS, the process ID, or
FG? No. FG by default will bring out the latest one. If you want to give the ID, then you will have to give this ID.
Okay. So where, I mean, FG one,
or even the PID, even the PID will work also. It's not like this will work. So.
Can you please bring that the 201 up? Bring the
which one? All of them are cancelled right now.
Done. Okay, it's cancelled.
But that will work. Just try in your VM. Just experiment in your VM regarding that. But do understand that what Control Z is doing here. Control Z is sending a signal stop. This kill -20 is also sending a signal stop. Now, whenever the process receives a signal stop command, it automatically gets sent to the background because the process has stopped. Now we don't want it in the foreground because there is no use of it being in the foreground. Otherwise, our terminal will hang. Because if we stop the process in the foreground, then there won't be any way to process go further from there. That's why it automatically sends to the background. Okay, the process automatically gets sent to the background.
Okay.
And why how the AND here is important is AND here is important because if we provide a AND, then the process starts in background itself. So if the process starts in background, then Control Z won't work because there is nothing in the foreground. And Control Z only acts on the foreground process. But kill command will work because terminal will be available. But if there is no AND command here, then this kill command won't be, you won't be able to enter the kill command because terminal will be occupied. But you will be able to run the Control Z. So in that case, Control Z will be the correct option.
Says please command, right? Instead of ampersand, we can also, there's a command, right? I remember.
Which one?
The CH or something like that, right? Instead of ampersand symbol, right? You can use some command to.
I believe there is a command. I'm not sure.
Yeah, you guys taught already, I think. Professor, I saw the notes. I forgot that. But.
So basically, the AND here is a built-in. It's a shell built-in, and the command would be a command. So.
Okay. Yeah, one dumb question. During the exam, right? Do we have access to VM or we don't?
No. You don't get. It's theory only. Theoretical.
Okay.
So question 5, I won't be doing any explanation as such because it's just asking to like which of the following actions will edit and add word EL to the start line and fifth line and save. You can run all of these in your like exactly how it is mentioned. You can just do a vi file name.txt and then run each of these to know which. So basically the editor questions, what you only have to prepare either vi or Emacs. I mean, it is up to you to learn both vi and Emacs, but only one will be sufficient to do the editor questions. And editor questions will be like this only. They'll ask you something simple like how to enter command at the fifth line, how to move cursor to the last line, how to, and or they will give you a like similar to the assignment question, like they'll give you a sequence of commands and then ask where the cursor will be. So only these type of questions will be there. You can refer to earlier term videos as well on PYQs to get a more sort of sense on how these editor questions will be structured. Okay. Coming to the sixth question. So question 6, now this sequence command and rev command, there are two commands here. But essentially what they are asking is they are asking the use of the piping and also the tail, which is the basic command. So that is why they have given the output of sequence. I'll quickly what you can infer from this is I'll quickly go through that also. So what sequence does is it prints a sequence, basically an advanced version of brace expansion. Sequence 10, 10, 40, what it will do is it will print from 10 to 40 at step size of 10. Okay, so basically 10, then 10 plus 10, which is 20, then 20 plus 10, which is 30, and 30 plus 10, which is 40. That is what it is doing here.
The second 10 is the steps.
One of them would be a step. Let me check. Second would be a step.
Yeah, please try 5.
Second one is a step. Second one would be a step.
10, 5, 10. What happens?
10, 5, 10 will give an interval of 5. Yeah.
Okay, so middle one is the increment.
It is like start, step, and.
Okay.
Achha, you
so
remember?
We cannot miss anything, right?
Huh?
We cannot skip anything. 3 of them are mandatory. All the 3 parameters are mandatory.
No. You can either it is this one or it is this one, start and end only. Or because in this case this will be equal to start, 1, end. That's the default behavior.
Thank you.
This is basically similar to the Python as well. In Python you had loops, right? And in loops you can provide a step size.
At the end. In Python the steps will be at the end, no? Here the steps is in between.
So that syntactical difference is there, but I mean conceptually they are similar.
We can use even.
Yeah, that's why it was confusing little bit. Normally the step will be at the end and optional if it is default to 1.
We can either use a single number also, we can use 2 numbers also, we can use 3 numbers. In all the 3 the situations will be different.
Okay. Achha, what will be the situation in a single number? Achha, in single number it will consider it will be like 1 till the end.
1 to 10, yes.
Achha, what will be a minus 10 then? Would it be something different or same? Nothing. Okay.
Minus 10 I never tried it.
Because dash won't work because it is not a minus 10. Dash 10 is essentially being represented as an option. That is why. But right now,
let's put minus 10 in bracket. Maybe it will work.
No, then nothing will happen. Bracket won't do anything. See? Okay. Because dash, everything beginning with a dash is an option, and without anything is an argument. So there's a difference between an option and an argument.
Sir, if you want to print numbers starting from -1 to -10, what will be the option in this case?
I'll have to check that. Maybe a sequence 10.
Single quote will take single quote or slash.
Let's try quotes. No, that won't do.
We can give the start as 10 and step as 1 and end as 0, no?
Yeah, maybe.
There is definitely a way to do it. There might be some.
Yeah, over there you get finer grained control over output with -f. There was a thing about.
Let me check.
In the screen they were going.
So I don't think there is a easy way to do it. It doesn't seem like there's an option to do it.
Can you just scroll the screen a little bit up? No.
Sir, I am not able to understand from the echo part.
Yeah. Over here, so you can get fine-grained control over output with -f.
Dash F and okay. So let's just try that. 9.2. 5.
We leave it, sir. We will practice it.
Acha, okay. You had to. Oh man. You had to give a ending one.
Okay, up to 2 decimal it is printing.
You have to specify a start and end. When you are doing negative numbers, no, you have to specify a start and end. It won't work with the 1 because it won't by default it considered 1 as the start now. So
okay,
it won't go in reverse, I believe.
So in this case, the minus dash also option is taking the option.
It is taking it. Yeah. Okay. So nice one. All right. Coming back, the important thing. Acha. Okay. So now I'll move on to the rev command. We have covered the sequence command in detail. Reverse command will reverse whatever. Okay. So there's a instead of there should be a should be text. This is text. Yeah, it reverses text line by line. Okay, so it won't reverse it won't do a 40. The standard output is 10, 20, 30, 40. It won't do this. What it will do is it will just reverse the line by line output. So instead of this is the standard output, so it would become 01, 02, 03, 04. So it line by line reverses. So this line will be reversed, this line will be reversed, and then this line, and then this line will be reversed. This is the behavior for almost all of the commands in Linux. They all work line by line. They don't work on multi-line. Always they take the input line by line. So even grep or sed or any other command, or tail or head or these commands also, they work line by line. Now, okay, so now we have sort of gone over sequence, we have gone over reverse. Now the only thing is left is the tail command, and tail command will, if you provide an option, then this is basically the number of lines from the end. So that's simple enough, and you can provide the tail -1, that will give you a 04, which is the answer. Okay, so that's the answer. All right.
Please explain a C command, SCA.
Which one?
First command is there, no? C, I think, no? Written there. Show the page once again, previous page. It is CSEA.
CSE. Acha, okay, this one. Which one? Where?
SEA.
Sequence command.
SEQ. It is SEQ, not SEA.
Okay. Yes.
Achha, so please watch the recording. This is being recorded. You can go ahead and watch the recording, and we just covered it in a lot of detail. So, please go ahead and watch the recording of this session. Okay, now going to question 7. So in question 7, the A and D options are correct, and it essentially, the question asks, so we'll show the output from ls with more command to see the page by page manner. So ls command basically lists the files, right? What the more command will do, right now there are only limited number of files, but if we had a lot of files, then the more command will do it in a multi-line fashion instead of printing out like this, only this much, because it right now only this much was able to get printed out, so it printed out the entire thing instead of going in the page by page manner. But instead, let me try this. Yeah, so now the readme file is a longer file, so it enters a page by page mode. Okay, so you can explore the more command in that regard.
Now what more is doing? What more is doing here?
Okay, so if you do a cat readme.md now, it will print this entire file, but it is taking more than terminal window, no? If we have to scroll,
Yeah.
So more command basically does is it prevents the scrolling, and you can then on a page by page manner view the file. instead of scrolling.
So how we will switch?
So here in this case,
How we will send? How we will scroll by the arrow key?
I mean, you can see in the exact navigation for the more command what it is, but that's not like important in this question. The important thing in this question is that the first they have asked the ls dash more, so this will work definitely. That's what we just talked about. Just essentially just pipes the output of ls to more. Okay, so this is essentially same as reading like whatever, like the maybe a file or whatever the output that more is getting from the pipe. The second one, what it does is it will take it as a string. So the only ls more will get printed out. It won't get evaled because this is a string now. It is not getting evaled. The last, this third command, what it will do is it will, this also won't work because now these will be interpreted as files, the ls and more, instead of being executed. Okay, please mute whoever it is. Okay, and the last one is the eval command. So eval is a special thing. Whatever you output in the eval now, whatever string the eval gets, eval will essentially eval it as a expression. So it's like similar to how you'll output in the how you'll write in the terminal. Eval will essentially be the same thing as how it is written in the terminal. That's why eval works. So that's why the first one and the second one are the correct options. Eight. Okay, coming to the eighth question. So this is a regex question. Okay, so the main concept they are asking is the regex only. They have listed grep command is what they're using. This is week 4. They're asking the regex for getting the MAC address. MAC address is a hexadecimal, as they have mentioned. A sample of MAC address they have given. They have also provided the field separator, and they have also mentioned that 6 hexadecimal numbers. Hexadecimal numbers are essentially 0 to 9 and A to F, be it capital or small. So, okay. So this is the thing where you have to run the grep command. And I'll have to explain you the regex. Let's go. So, okay, so notice one difference. They have provided that dash E will enables the extended ERE, and dash O will only print the matched output. And so in some cases, the extended version is not there, and in some cases, the extended version is there. So there is a difference between the regexes, between extended and the basic versions. So this is the regex that we have been given. I'll explain this regex. First, let me just write some string here. A8, C9, 0D. Okay, then. Okay, so this is a valid MAC address. Also, let me just give you another MAC address, which is also valid. So essentially, dash is also a valid separator for MAC addresses. Okay. So what the first part is doing, this one. This is the character class, which will match anything from 0 to 9, A to F, or small a to small f. Okay. And we want 2 of these because we have 2 of these in the beginning. So we have 2 of these. So we want to just match first 2, and then we have a colon. Then it is asking either match a colon or a dash. So what? So AB dash. So what this entire group is doing now? There is a group here. It is bracketed. So what this entire part is doing? It will be matching this AB dash or AB colon. Okay. Now once we have gotten this, now we just want all of this to be matched 5 times. So basically these many times.
Please explain once.
These 5 matches. So all of these will be so one is this. second will be this this entire thing, then third will be this entire thing, fourth will be this entire thing, and fifth will be this entire thing. Okay, so 5 of these we are being considered. First, this is the group, then 5 of these groups, which will be this. Then we have covered the first part of this thing. Now coming to the last part. Last part is nothing, just different. It just matches the same thing as this first thing, and only it excludes the space separator because there is no separator at the end of the MAC address. So that's how it is. Any questions regarding this regex? Okay, so any questions?
Sir, AB, please explain the steps, sir. AB colon, sir. AB dash.
So what I just listed is that I just wanted to give you an example as to what it will match. So basically, it will be A to Z. Oh, sorry, A to F, and 0 to 9. Anything here. So 2 of these, essentially 2 characters. So if I'll remove everything here, from everything I'll remove everything here, and let's take a look at this only. Okay, so now you can see we are matching the 2 characters. Let me even remove the 2 here. Okay, so now like we are individually matching, but not as a group we are matching. If you put a group, then it will match as a group, both of these characters. So that's just the like the first part. Now let's proceed. Now we want to match either a colon or a dash. So for that we'll put another character class and a colon and a dash. Now we are matching colon 1 and a dash 1. But all of these are individual matches. We want to match this thing entirely, right? So these are individual matches, but we want to match this thing entirely. So what we will do is we can put all of this in a group, and then we can put a quantifier ahead of them. So 5 of these that will match this entire thing. So this is one match, this is one match, this is also a match. After that we can simply repeat what we covered in the first because we only want to match the 2 characters, so we can do just this A to F, and then just put a 2 here. That will match the ending ones also. So that is this regex, that what it is doing.
And what is a colon and a hyphen other than a special character in the MAC address? Only 2.
So colon and hyphen, because these are the valid separators, no? So I mean,
only
comma,
these 2.
Comma is not a separator valid here. Comma won't match. Comma because only we want colon and a dash.
My question is, the colon and hyphen only is permissible other than the number and text, right?
Okay. Correct.
Okay, thank you.
Okay, so that covers the.
Sir, what does 5 represent?
5 is the quantifier. It basically means the 5 of these. This 1, then 2, then 3 of this group.
Okay, so basically in the first bracket, the pattern has to be followed, and it is like it should be 2 digits before the colons or the hyphen, and 5 times.
Correct. You are correct.
5 times, and for the end part, because it doesn't have any
colon. So we removed it. We removed from the end.
Okay, sir, got it now.
So can we have that back reference? We are writing 2 times, right? The 0 T.
We can use a back reference. I mean, no.
Not because we repeat the.
No, we are not exactly repeating, because we are putting the colon inside the matched thing. If we'll
what about the first group, the 0 to.
What we can do is, I mean, this is a bit advanced. So what we can do?
Let's leave it then.
Yeah. We can do this. I mean, don't expect this to come, but I'll try this once. Control X, Control V here. Then I can remove this, and then I can provide a \1. Will this work?
2 times.
List details. Okay, remove. Group is, what is the group? FF is the group.
It's okay.
No,
Sorry.
no. Back reference won't work. We have to provide the regex.
Mhm.
Back reference won't work here. Back reference will only work if we want to match something like the last one. No? So let's say we want a MAC address where the last two like are same. Last two lines are same. Then we can use a back reference, or maybe I can change here E to FE to FE. So now it works. So that way it will work, but it won't like replace the regex itself. It wants a variable, the whatever the capture group is assigning as a variable that it wants when it is doing back referencing.
Okay, thank you.
Sir, here, sir, in the first option, sir,
Huh.
please show the page, previous page.
Previous page, yes.
Yes. Here, sir, 2 in bracket means they are taking 2 bits at a time, no, sir?
Two of whatever this is.
Okay. After that, colon minus means they are combined taking 3 bits, either 2 bits with colon or 2 bits with dash.
No, 3 kahan se aa gaye? From where did 3 come from?
No. Colon and minus given, na? That's why.
No, colon and minus, so we are matching either a colon or a minus or a dash. Either a colon or a dash. Either this colon or a dash. I mean, because we can have a dash also as a separator. That is why.
Sir, in the next, again they are given 0 minus 9a. That means both are selecting, na?
The last one is selecting only this part. You can in fact go in detail also. So the first group will, the last group is selecting the last FE part only. I can change it to a AA, let's say. It's only the last part. So only this much. Because we want this X, why we are not using 6 here is because we don't want a colon and a dash in the end. That is why. That is why we have to separate it like this. It is same as matching the first 2 characters. Okay. Okay. So that covers the first option. I'll also explain the fifth option. Fifth option, there is a character class, which essentially is equal to the 09AF thing. X digit is equal to hexadecimal. I have written this also here. So X digit matches hexadecimal. Okay. So basically this X digit is equal to 09AF thing. You can search for POSIX classes and whenever like in Google to get all the classes there are. The C option has bunch of backslashes. That is because it is a basic regex. Okay, so basic version requires you to put backslashes. It's just a difference, syntactical difference, which basic has compared to the extended version. Nothing special about it. So in the like question paper, I mean, you can look for if you like what I tell is to practice the extended version. So what happens if a basic version comes? So in basic version, in the like mostly the regex will remain same. Only thing that will be added are like some backslashes. So there are like minute differences which you should be aware of. Apart from that, there won't be any major differences. And the fourth option is clearly wrong because we don't want lnum, and also it is using forward slashes, so, which is incorrect. Lnum will match it will match ABCD, EFG, HI, JK, LM, no P till Z. We don't want that because hexadecimal is only till F. Okay. So moving on. Any question anyone was turning on their mind?
So one question, sir. In this backslash thing, there are certain brackets where they are not using backslashes. So where they use backslash and where they don't, like the square brackets which they are using, they are not using any kind of backslash.
So you'll have to go through the definitions, like syntactical definition of basic one to get the entire picture.
So in the basic regex, we have to search for this usage of backslash.
You can search for that. These are just some minute. There are just some minute differences which we will have to take care. Like if you put a plus quantifier in extended rejects, you can put a like a plus quantifier. Maybe I can just show you.
Repeat more than one times. It means
A plus,
repeating
right?
it more than
A
one.
plus.
Yeah.
So this will match basically if any number
Matching
of
it more
A's
than
at
one, then
least.
yes. Yes.
So this is in extended version. If I want to do basic now, I will have to put a backslash here. But in extended one, it's opposite. In extended one, it actually escapes. But in basic one, this is the default is escape. So these differences are there, mostly
What is the
concerning the.
confusion? The confusion in basic mainly is to where to use this bashless thing. Somewhere they don't use this. Somewhere they
Yeah,
use it.
like that's why I keep telling everyone, practice with the extended thing only. We won't give you options where we will ask you, like we won't give you two options where we will put backslash in front of one bracket pair and backslash not put bracket in front of one another pair, because that isn't making any point, and it isn't useful.
Right. Understood.
So
Means wherever there is a
uh,
backslash use, we should interpret as it
so
is a correct thing. It is a correct thing. If it matches
I mean,
the yeah.
you should still be aware of like something, but don't be worried that we would ask you to split out this difference.
Okay, understood. Thanks.
Sir, please explain the X digit part from the E option.
X digit is equal to 09 thing. This is equal to this part. Okay. This whatever this is there in the bracket now 09 A to F, and A to F is equal to X digit. Nothing more. Simple. So, okay. Question 9. Achha. This is also where okay. So question 9 basically this is the common data that they have given for following questions, right? Also do note that there is the output here is a part. So please focus here. They have mentioned that this is a part of the entire output. Okay. I mean, they should have. It should be highlighted a bit more. That is true. I'm not sure if it was highlighted in the actual paper, but do note that this is a part of the entire output, not the entire output. Okay. So following is a part of entire output of ls-la from a directory. What they have asked in the first question is how many soft links are present. So in soft link, you have to do nothing. I mean, you only have to count these things. These like there is a L beginning with all of the L ones. So there's one here and another one here. Okay. So you only have to count the L ones. That is easy. Moving on.
Sir, suppose we in question we asked if how many hard links is there in the question, then how can we solve?
Hard links is the number here. This number represents the hard link.
You mean the directory?
These numbers. The like this. This has only one hard link. These has 5 hard links. This has 3 hard links. It's like that.
We have to differentiate between hard link and soft link with the second column only.
How differentiate?
By seeing if suppose in this page itself, if there are hard links, then how can we differentiate between soft link and hard link?
Soft link would always have this format. There would be a dash and an arrow pointer, and it will always represent a L in front of it. And hard links are essentially same names, like they are just different names for the same location. So they won't be given like specifically. They won't be printed out. These two are hard links. But if you will put if someone wants to ask you hard links, they'll give you the output with the inode number. Like they'll give you this output instead of that output.
If the inode numbers are same, then we will.
The inode numbers are same, meaning they are hard links. Okay, so first question is simple enough. Moving on. I mean, I have also listed out here. Count lines beginning with L. The 10th question is where a lot of people get confused. So it mentions that assume that each directory has two hard links, one for current and another from its parent. So now this line, the two hard links which are mentioned here are these two. The one hard link is in the parent directory for the name of the directory. Another hard link is in the directory itself. So the cd dot command, whenever you are in directory and if you execute the cd dot, you will be there itself. You won't go anywhere else. So this is also a hard link for the directory itself. So these are the two hard links which are mentioned. Apart from these two hard links, any other hard link is present in the subdirectories only. Okay. So like whenever the question asks how many subdirectories are present in the current working directory, then you can apply this sort of formula. Subdirectory is equal to number of total hard links minus 2, which the two we are excluding are the ones which the directory has it for itself, and the one which is in the parent directory for the directory name. Okay.
Sir, how did you get 16? Like, I couldn't understand.
16 is mentioned here. For the directory, 16 was mentioned here. So dot is the current directory itself, and 16 was mentioned for this. These are the number of hard links.
Okay, sir.
Okay.
Means the present directory has 16 hard links.
That is correct. Okay. So 16 means this is one in the parent one, and then in itself the dot one, and apart from that any hard link are the subdirectories. So we have 14 subdirectories in this case, 16 minus 2, 14, and each of them will have a link which is double dot. So if you go into a directory and you type double dot, it takes you back to the previous directory. So that is essentially a hard link to this directory itself. If you compare the inode, so this dot has a inode number of 90438, and if I go into the test and do a here, so you can see the double dot has the same inode number 90438. That is why. So you can check this out further. Basically, this is what the hard links regarding directory are there. Achha, question 11 is theoretical only. It's nothing, I mean, it's just straight theory. You can see the documentation for what each of the, it essentially asks the first letter of each, what it signifies. So D signifies a directory, C signifies a character file, L signifies a link. So these are the only three things that are present. So B is hard link, B is a directory, D is for soft symbolic links, and E is for character files. Okay. So you can refer to the documentation as to what each of the code will correspond to which sort of file.
Sir, why is option C incorrect? Like hard link are present in each directory, right? Then why?
For the given form, which of the following types are present in the list? For the given option, which of the following types are present in the list? Okay. See, although you can't comment about hard links because they haven't given you an inode number. If they had given you an inode number, then you could have commented that hard links are present in the current working directory. By what is meant by hard link is that hard link like two files which are hard link of each other are present, right? Right now we can only comment that okay, this is a thing and it has hard links. They may not be in this directory itself.
Okay, sir.
Sir, one branch question to this, like you said just now, said that inode number will be given. Now suppose two inode numbers are matching, and if they are asking how many hard links are present, in that case we'll write 1 or 2.
Don't write. I mean, you will write 2, 1 or 2. That's a good question. You'll write 2. 2 hard links.
Write 2. Okay, if two inode numbers are matching, then we'll write two hard links.
Sir, please. So, sir, I want to see the formulation. I think. Suppose here current directory has 16 hard link. That means current directory and parent. That means I can say this directory contains 14 subdirectories or files. Can I say, sir, this formula?
That is exactly what you can say.
As for example, this block file has two hard links. That means the directory itself and its parent directory. That means it has no files.
No subdirectories.
No present files are present.
Block directory doesn't have any further subdirectories.
Yes. Similarly, sir, like here one is there for the character file dxg. Okay. Second from the last. Okay. One means the directory itself. That means
no, correct. It is not a directory. It is the character file. It is a file.
Here, what is the meaning of one hard link one?
One means that it is like there is only one name associated with this address.
No parent.
Parent concept is not here because it is a file.
Okay.
Parent concept is parent and sub directory concept. Child concept is in directory only. But the one here means that there is only one link here. So if it would have been two, another one, then this would have been two.
Sir, I cannot open this dxg with the cd comment.
Which you can open dxg with? No, you cannot. You cannot.
That's why.
Character file, no, it is a file. It is not a directory.
Okay, sir. Okay, thank you.
Okay, so we'll go to the 12th question. I mean, even here the question itself is not really something that I cover. Basically, all of these are different ways to get the some sort of information about the commands. Maybe where they are stored, or maybe a propose gives a basic one-liner description. Info gives a shorter version of man. You just have to look which like option corresponds to the same output as the man-k thing. You will have to look about this in the VM. Question 13 is out of syllabus. It is maybe a week 5 question. I'm not sure, but this is this won't be this type of question won't be coming in the exam. Week 5 question. Question 14 is the last question. Here also they have. So first, what they are doing is they are using grep for filtering out the IP addresses in this output. Then they are using a sort command, which will, I mean, as the name suggests, it will sort the number or the IP addresses, and then the unique with a -c prefix will put a number in front of it will, like if there is a repetition, like there is a 1.1 and a 1.1 here, so the sort command will put can I copy this? Yeah, I can show you after running itself. Okay. Yeah, see, this is the entire output, and the grep command will just filter out all the IP addresses. Okay, so let's just proceed with that. I'll explain the rejects in a bit. First, I'll just cover the piping thing that they are doing. So this is the output of the grep. Then they are passing it to the sort command, which will essentially sort all of them. And the unique command, so now you can see that 1.1 is next to 1.1, then there's a 1.2 is next to 1.2, and 1.3 similar. Now just a unique command with a -c option will just provide a number in front of it. Will remove all the duplicates and replace them with a number in front of each of them. So 2 for 1.1, 2 for 1.2, and 1 for 1.3. Okay, so that is what the piping thing is doing. I'll just explain what the regex is doing if you want. Basically, regex here is not important as such because they are asking what the command will output, and I mean you can I mean, you sort of interpret the rejects in a way. Yeah. Okay, so like this backslash b, it is a word boundary. You can refer the cheat sheet here on the left as well. Word boundary will essentially match anything, either begin or with a nothing. It should end with nothing, or it should begin and contain a white space, or it should have white space at both ends. So that's what a word boundary. Essentially, whatever you will consider a word now, that's what is meant by a word boundary. Like I can't put a here, I can't put a dot here. I mean, dot can be, because dot is also a word, because in grammar you end with a dot, right? So that is also considered as a word boundary. Okay, so basically any character apart from punctuations or white spaces will be a valid word boundary. So they are only doing that. Even in this case, right now, if I remove one, now what they are doing, they want correct numbers from 0 to 9. Acha, do note that this is not a valid IP address match. I mean, it will match a IP address, but it will also match like 999. But 999 can't be a valid IP address. IP address is only limited to 255. So that's not really relevant, but if they can formulate the question, they can ask you, they can give you that 255 is the limit, and if will the rejects match valid IP addresses only. So in that case, you'll have to know this. Then we just want like 3 digits. So from 1 till 3. It can be either 1 or 2 or 3. We don't care about that. So that just matches the digits. Then it's an escape dot, because dot has a special meaning. Dot is a wildcard character. It matches anything except white spaces. So that's why they have escaped it here. Except, sorry, new lines. Except new lines. So that's why they've escaped here for the dot. And then this is the similar behavior which we observed earlier. Because we don't want a dot in the end, we are repeating the rejects. Okay. Any questions regarding this?
If we want for valid IP address means 255 means what would be the rejects then?
255, the rejects for that would be, I mean, it would be a much more complicated. So first, at the first end, you will just limit it to 1, 2. So, and you can remove this. Okay. You will want 1, 2, and what you will want is 255, right? Want to match 0 till 5. All of this. Then 0 to 5. This could be a question.
We can also use curly braces after 0 to 5, no? Matching 2 times.
Now, see, again, that won't, because the back reference doesn't include the rejects. It includes the actual match. So then 254 won't be matched. I mean, matching like a IP address. See, this is how all of that becomes complicated, because now
this 0 to 5 will not cover number 9. No, if it is a 249.
That is why the like rejects gets
it will be complicated.
This will be matching 294. So you'll have to find a way to somehow limit it. In fact, I'll have to even look that up for a valid IP address match. What would be the proper rejects? You can look that up on Google. Okay, that's what will be the. It's probably a really long rejects.
So do you have the PDF version of the cheat sheet that you're using, of the regex cheat sheet?
This PDF version of this? No, I
Yeah,
don't
on
have
the
it.
left one. Yeah. Yes. Okay.
You can maybe go to the site rejexer.com. You can copy the link and then you
Okay.
can maybe take a screenshot or just copy everything here and put it in a file and make a PDF. If you
What is this question mark is doing? Either
this is
1 2 or
ignore. Acha, right now. So
Yeah.
this is just telling that we want first digit or not want first digit. So this is, I mean, so that is what it's making. If I remove the question mark here, then this won't match.
Okay.
Oh, ignore that. I mean, it is out. So I mean,
Okay.
should I believe I can stop the recording now. Stop the streaming.
The recording link was set as private.
It is better keep the recording because it will be better for us. We'll do it again.
No. So recording will be made available. You can see right now it is private. It will be public when I'll stop it. Okay.
Okay.
So I mean it's already 1.5 hours. I believe it's fine. We can stop on 1.5 hours. But I'll continue the session. The session continues, so you can ask your doubts. I'll just stop the recording here. Streaming.